International Baccalaureate, or IB, Environmental Systems and Societies, ESS. I am Dr. SEKHAR, Associate Dean and Professor and an IB ESS expert. This lecture series introduces one of the most interdisciplinary subjects in environmental education, combining science, social systems and sustainability to understand the relationship between humans and the natural world. At the center of the course is the idea of environmental systems, interconnected components that interact through inputs, outputs, energy flow and feedback mechanisms. ESS encourages students to study environmental value systems, systems thinking, equilibrium, sustainability, ecological footprints and carrying capacity. These concepts help explain how ecosystems respond to both natural processes and human activities. The diagram on the right highlights the ESS systems approach. Perspectives influence how societies value nature and make environmental decisions. Human-environment interactions examine how activities such as urbanization, agriculture, energy production, and consumption alter ecosystems. Systems thinking focuses on the interdependence of environmental, economic, and social components, while sustainability emphasizes meeting present needs without compromising future generations. The imagery of solar panels, wind turbines and green urban landscapes represents renewable energy transitions and sustainable development strategies already being implemented worldwide. For example, countries such as Denmark increasingly rely on wind energy, while Singapore integrates urban planning with green infrastructure. ESS develops critical thinking and evidence-based learning skills, enabling students to analyze environmental challenges such as climate change, biodiversity loss and resource depletion from both scientific and societal perspectives. Environmental Systems and Societies, or ESS, aims to empower and equip students with the knowledge, analytical skills, and ethical awareness required to understand and address environmental challenges at both local and global scales. The first objective focuses on developing an understanding of individual environmental impact within the broader context of humanity's influence on Earth systems and the biosphere. The Earth illustration surrounded by urban structures, vegetation, and renewable energy technologies such as wind turbines represents the interconnectedness of human systems and natural systems. Students are encouraged to reflect on how activities like fossil fuel combustion, deforestation, and urban expansion influence atmospheric composition, biodiversity, and ecosystem stability. For example, increasing carbon emissions contribute directly to enhanced greenhouse effects and global climate change. The second aim emphasizes developing knowledge of diverse perspectives related to sustainability. The interconnected human figures surrounding the globe symbolize cultural, economic, scientific, social, and ethical viewpoints. Environmental issues rarely have a single solution. For instance, debates surrounding mining projects may involve economic development benefits while simultaneously raising concerns about habitat destruction and indigenous land rights. ESS students therefore learn to evaluate multiple perspectives before making informed conclusions. The third objective highlights engagement with environmental tensions using critical thinking. The balance scale visually represents the challenge of balancing environmental conservation with industrial growth and economic demands. Students analyze scientific evidence, question assumptions, and make ethical judgments. A practical example is balancing energy security with reducing greenhouse gas emissions during the transition from fossil fuels to renewable energy systems. The fourth section introduces the systems approach, a central ESS concept. The circular systems diagram demonstrates interactions among environment, technology, society, and economy. ESS students examine how changes in one component affect the entire system. For example, rapid industrialization may increase economic growth but can also intensify pollution, resource depletion, and public health risks. Systems thinking allows students to understand these complex feedback relationships. Finally, the fifth aim encourages students to engage actively in environmental issues across local and global contexts. The image of students planting trees and promoting the message, "Act local, think global," represents informed environmental action. Real-world examples include community waste management programs, biodiversity conservation projects, water conservation initiatives, and climate activism. ESS ultimately empowers students to think critically, analyze systems scientifically, consider multiple perspectives responsibly, and contribute toward a more sustainable future. Welcome to Topic 1 of IB Environmental Systems and Societies, Foundations, Perspectives, Systems, and Sustainability. This topic introduces the core principles that form the conceptual framework of ESS and provides the scientific and analytical foundation for understanding environmental issues. The large Earth image combined with forests, rivers, solar panels, and wind turbines represents the interaction between natural ecosystems and human technological systems. These visuals emphasize renewable energy, ecosystem conservation, and sustainable resource management. For example, solar and wind energy systems are increasingly used worldwide to reduce dependence on fossil fuels and lower greenhouse gas emissions, contributing to climate change. At the center, the concepts of perspectives, systems, and sustainability define the ESS approach. Perspectives refer to different ways of seeing and valuing the world. Environmental decisions are influenced by cultural, economic, ethical, and political viewpoints. For instance, forest conservation may be viewed differently by indigenous communities, industries, and governments. The systems diagram illustrates how human-environment interactions occur within interconnected environmental systems. ESS studies inputs, outputs, energy flows, matter cycling, and feedback mechanisms within ecosystems and societies. Positive feedback loops amplify change, while negative feedback loops stabilize systems and maintain equilibrium. Climate change provides a strong example, where melting Arctic ice reduces surface albedo, increasing heat absorption and accelerating warming. Sustainability focuses on meeting present needs without compromising the ability of future generations to meet their own needs. The urban green city landscape symbolizes sustainable development through renewable energy integration, efficient transportation, green infrastructure, and water conservation. The icons at the bottom introduce key ESS concepts including environmental value systems, systems and models, feedback mechanisms, equilibrium, sustainability, natural capital, ecological footprint, and carrying capacity. Together, these concepts help students scientifically analyze environmental challenges and evaluate sustainable solutions for the future. A perspective is the way a particular situation is viewed, interpreted, and understood by an individual or group. In environmental systems and societies, perspectives are extremely important because environmental decisions are rarely based only on scientific data. They are also shaped by personal experiences, cultural influences, ethical beliefs, and social values. The diagram begins by showing that perspectives are based on a combination of personal assumptions, collective assumptions, and values and beliefs. Personal assumptions develop through individual experiences, education, family background, and lifestyle. Collective assumptions arise from shared cultural norms, traditions, religion, politics, and community expectations. Values and beliefs determine what people consider important, ethical, or acceptable in society. Together, these factors influence how environmental and social issues are interpreted. The central concept defines perspective as how a particular situation is viewed and understood by an individual. Different people can observe the same environmental issue but reach very different conclusions. For example, a hydroelectric dam may be viewed positively by governments because it generates renewable energy and economic development, while local communities may oppose it because of displacement, habitat destruction, and altered river ecosystems. The diagram also explains that personal perspectives create a wide range of positions on environmental and social issues. Some individuals prioritize economic growth and industrial expansion, whereas others emphasize biodiversity conservation, climate stability, and environmental protection. These contrasting viewpoints often influence environmental policy debates and sustainability strategies. Perspectives directly influence people's choices and actions. This is illustrated through examples such as how we use resources, how we treat others, the issues we speak up about, what products we buy and support, and how we care for the environment. For instance, individuals with strong environmental values may reduce plastic consumption, conserve water, use renewable energy, or support sustainable businesses. Conversely, consumer choices driven mainly by convenience or profit may increase resource depletion and pollution. Overall, understanding perspectives helps ESS students recognize why environmental conflicts occur and why sustainable solutions require balancing scientific evidence with social, cultural, economic, and ethical considerations. Perspectives are informed and justified by many interconnected factors that shape how individuals and societies understand environmental and social issues. In ESS, a perspective is defined as a way of viewing and understanding the world and particular situations. These viewpoints influence environmental decisions, public behavior, and sustainability policies. One major influence is socio-cultural norms, including shared traditions, language, customs, and social values. These factors affect how communities interact with natural resources. For example, some indigenous societies emphasize conservation and sustainable harvesting practices because of strong cultural relationships with ecosystems. Scientific understandings also shape perspectives through accepted evidence, observations, and scientific methods. Climate science, biodiversity studies, and ecological monitoring provide data that influence environmental awareness and policy decisions. For instance, evidence linking greenhouse gas emissions to global warming has strengthened international climate agreements and renewable energy transitions. Laws and policies influence perspectives by establishing legal responsibilities and acceptable actions. Environmental regulations such as carbon emission limits, plastic bans, and protected area legislation shape how societies manage resources and environmental risks. Religion and spirituality are another important influence. Many belief systems encourage stewardship, ethical responsibility, and respect for nature. Religious teachings can influence attitudes toward conservation, consumption, and environmental justice. Economic conditions also strongly affect perspectives. Wealth, employment opportunities, resource access, and inequality influence environmental priorities. Developing countries may prioritize economic growth and industrialization, while wealthier societies may focus more on pollution reduction and sustainable technologies. Lived experience further shapes viewpoints through personal observations and environmental exposure. Communities directly affected by floods, droughts, pollution, or deforestation often develop stronger awareness of environmental risks and sustainability needs. Similarly, local and global events such as natural disasters, pandemics, and energy crises influence public opinion and policy priorities. The lower section distinguishes a perspective from an argument. A perspective is a viewpoint shaped by values, experiences, and influences, whereas an argument is a reasoned explanation using evidence, logic, and analysis to support or challenge a perspective. For example, a person may hold the perspective that renewable energy is essential for sustainability, while scientific data on carbon emissions and climate change are used as arguments to justify that position. Overall, ESS emphasizes that people form perspectives through multiple influences and then use arguments, evidence, and reasoning to explain, defend, or question those perspectives in environmental decision-making. Values are the guiding principles and qualities that people consider important in life, and they strongly influence how individuals understand environmental and social issues. In environmental systems and societies, values are essential because they shape human behavior, environmental decision-making, and sustainability practices. At the center of the framework is the concept of values, represented by the heart symbol, emphasizing care, responsibility, and ethical decision-making. Values influence how people think and decide by shaping their priorities, judgments, perspectives, and choices. For example, individuals who value environmental protection may prioritize renewable energy, biodiversity conservation, and sustainable lifestyles, whereas others may focus more on economic growth or technological development. The diagram also explains that values are individual but shared. Although personal values differ from one person to another, many are influenced collectively through communities, cultures, and societies. Shared environmental values can encourage collective action such as recycling programs, climate campaigns, or conservation initiatives. A practical example is community participation in reducing plastic waste through local bans on single-use plastics. Another important aspect is that values are shaped by others in our community. Family and friends influence attitudes and behaviors from an early age. Culture and traditions shape perceptions of resource use and environmental responsibility. Religion and belief systems often encourage stewardship, compassion, and ethical treatment of nature. Community norms and global events also influence public priorities. For instance, severe floods, droughts, or wildfires can increase public awareness about climate change and environmental sustainability. The examples listed on the right, respect for nature, honesty, compassion, justice and fairness, responsibility, and creativity, are all important environmental values. Respect for nature supports biodiversity conservation, while responsibility encourages sustainable resource management and reduced ecological footprints. Justice and fairness are especially important in discussions of environmental inequality and climate justice, where vulnerable communities are often disproportionately affected by pollution and resource scarcity. In essence, values guide what people consider important, influence how the world is viewed, and shape everyday environmental choices and actions. Understanding values therefore helps ESS students analyze why societies make different environmental decisions and how ethical principles influence sustainability strategies. Values influence both individual behavior and organizational decision-making, and they play a major role in shaping perspectives on environmental and social issues. In ESS, values are not only personal beliefs, they are expressed through communication, policies, actions, and interactions within society. The central concept shown here is that values shape our perspectives. In our communication and actions with the wider community, values influence how we speak, how we treat others, how we participate in society, and the choices we make in daily life. For example, individuals who value environmental sustainability may choose public transportation, reduce plastic consumption, conserve energy, or participate in community cleanup campaigns. Respect, cooperation, and social responsibility are often reflected through these actions. Values are also visible within organizations. Institutions, companies, governments, and media organizations communicate their values through advertisements, corporate messaging, public policies, sustainability reports, and environmental initiatives. For instance, some companies promote renewable energy use and carbon neutrality as part of their corporate sustainability strategies, while others may prioritize profit maximization and industrial expansion. Policies and guidelines therefore reveal the priorities and ethical principles of organizations. The lower section explains that different values often lead to tensions and conflicts. Between individuals, disagreements may arise over environmental protection versus economic development, or over lifestyle choices such as consumption patterns, transportation preferences, and dietary habits. A common example is the debate between conserving forests for biodiversity protection and clearing land for infrastructure or agriculture. Conflicts also occur between organizations. Some businesses prioritize short-term economic gains, while environmental groups emphasize long-term sustainability and social responsibility. These tensions are common in issues such as fossil fuel extraction, mining projects, dam construction, and industrial development. For example, oil companies may argue for energy security and employment opportunities, whereas environmental organizations may focus on carbon emissions, ecosystem degradation, and climate change impacts. The key idea is that values strongly influence how individuals and organizations operate. These values are expressed through communication, media, policies, and actions, and when values differ, environmental and social tensions naturally emerge. Understanding these differences is essential in ESS because sustainable solutions often require balancing competing priorities, perspectives, and ethical considerations. Values surveys are important tools used to investigate how different social groups perceive environmental issues and sustainability challenges. In ESS, these surveys help researchers understand what people believe, what they consider important, and how their values influence environmental decision-making and behavior. The first section explains that values surveys focus on a particular social group and explore attitudes, priorities, and viewpoints regarding environmental issues. These surveys can reveal differences in perspectives within a community and help explain why people may support or oppose environmental policies. For example, when studying the protection of wetlands, some individuals may value biodiversity conservation, while others may prioritize economic development or land use for agriculture and infrastructure. The second section focuses on the effective design of values surveys. Good survey design must include diverse viewpoints and experiences to avoid bias and improve reliability. Open and balanced questions are essential because leading questions may influence responses and reduce objectivity. Surveys should also assess how perspectives are likely to impact environmental issues and ensure cultural sensitivity and clarity. For instance, questions about renewable energy adoption should consider economic affordability, cultural acceptance, and access to technology within different communities. The process section outlines how surveys move from data collection to informed action. The first step is designing the survey by selecting the environmental issue, identifying the target group, and preparing questions that capture a range of values. The next step involves collecting responses through online surveys, paper questionnaires, interviews, or focus groups. After data collection, perspectives are analyzed to identify similarities, patterns, and differences in values and priorities. Statistical tools such as percentages, frequency tables, and correlation analysis may then be used to interpret the findings. The survey results are then used to assess environmental impacts and guide communication, education, policies, and community action. For example, a survey investigating attitudes toward plastic reduction may help governments design more effective waste management campaigns and recycling policies. The wetland conservation example at the bottom illustrates how values surveys can explore questions related to biodiversity, recreation, economic use, and public willingness to support conservation measures. A clear understanding of different perspectives helps decision-makers develop solutions that are inclusive, socially accepted, and more likely to achieve long-term environmental sustainability. Application of skills in surveying perspectives is an important ESS approach used to understand how people perceive environmental and sustainability issues, and how these perspectives influence attitudes, behaviors, and decision-making. The central goal shown here is understanding perspectives on environmental and sustainability issues through systematic data collection and analysis. The first stage involves designing and collecting data. Information can be gathered using questionnaires, online surveys, structured or semi-structured interviews, collaborative survey tools, and community feedback methods such as focus groups or public forums. Good survey design is essential to improve reliability and reduce bias. Researchers must clearly define the purpose of the investigation, identify the target social group, select measurable variables, and use neutral, unbiased questions. For example, a survey investigating recycling behavior should avoid emotionally leading language that could influence responses. The second section identifies environmental and sustainability issues commonly investigated through surveys. These include climate change, plastic pollution, water conservation, renewable energy, waste segregation, and sustainable transportation. Such issues are globally significant because they affect ecosystems, resource availability, greenhouse gas emissions, and public health. For instance, surveys on sustainable transport can help determine whether communities are willing to reduce private vehicle use to lower urban air pollution and carbon emissions. The third stage explains how perspectives are correlated with attitudes and behavior. Environmental concern, economic priorities, social responsibility, lifestyle choices, and conservation ethics influence how people think and act. These perspectives shape attitudes such as willingness to participate in sustainability programs or support environmental policies. Behavioral outcomes may include recycling frequency, energy-saving practices, reduced plastic use, or participation in conservation initiatives. Correlation analysis helps identify relationships between variables, such as the connection between environmental awareness and recycling behavior. The fourth component introduces statistical tools used to analyze survey data. Bar graphs and pie charts summarize frequencies and proportions, while statistical measures such as mean, median, mode, and percentages describe trends within the data set. Correlation analysis, frequency tables, and trend analysis are then used to identify relationships, patterns, and outliers. Pearson correlation coefficients, for example, measure the strength of relationships between environmental attitudes and sustainable behaviors. The fifth section demonstrates the use of behavior time graphs to monitor lifestyle changes over time following awareness campaigns or interventions. The graph illustrates increasing trends in recycling, public transport use, reduced plastic consumption, and energy-saving behavior over several months. These graphs help evaluate the effectiveness of environmental education programs, sustainability campaigns, or policy measures. The final outcomes emphasize moving from data to informed decisions. Survey findings help identify attitudes, predict behavioral trends, guide environmental policies, support community action, and promote informed sustainability decision-making. The key takeaway is that well-designed surveys, appropriate statistical analysis, and behavioral trend monitoring help connect perspectives with actions, leading to more effective environmental solutions and sustainability strategies. This example demonstrates how ESS students can apply survey techniques to investigate perspectives on plastic pollution within a school community. The environmental issue being explored is the use of single-use plastics and how attitudes and behaviors influence plastic waste reduction. Plastic pollution is a major global environmental problem because plastics are non-biodegradable, persist in ecosystems for long periods, and contribute to land, freshwater, and marine pollution. The first section explains the aim of the survey, which is to investigate how students' and teachers' perspectives influence their behaviors toward reducing plastic waste. The survey seeks to understand levels of environmental concern, everyday consumption habits, and support for reducing or banning single-use plastics in schools. For example, students who regularly use reusable water bottles may demonstrate stronger pro-environmental attitudes compared with those relying on disposable plastics. The target social group includes students from grades 9 to 12, teachers, and school staff. These groups were selected because each has different responsibilities, experiences, and environmental perspectives that may influence decision-making and sustainability practices within the school. The sample size shown includes 96 students, 18 teachers, and 6 staff members, giving a total of 120 respondents. The pie chart indicates that students represent 80% of the sample population, teachers 15%, and staff 5%. This distribution allows researchers to compare perspectives between groups and identify patterns in attitudes and behaviors. The data collection methods involve questionnaires and online surveys using platforms such as Google Forms and Microsoft Forms. Online surveys are efficient because they are easy to distribute, allow anonymous participation, and simplify statistical analysis. Sample questions investigate concern about plastic pollution, use of reusable water bottles, support for banning single-use plastics, and the factors influencing opinions, including environmental protection, cost, convenience, and social influence. These questions help measure both attitudes and behavioral intentions. The final section highlights the next steps. The collected data will be analyzed using graphs, tables, percentages, and correlation analysis to identify trends and relationships. Behavior time graphs may also be used to track changes in plastic use over time following awareness campaigns or school sustainability initiatives. Such investigations help schools design evidence-based environmental policies, improve waste management strategies, and promote long-term sustainable behavior within the community. This example demonstrates how statistical analysis and behavior time graphs can be used to investigate perspectives and behavioral responses related to plastic pollution within a school community. The environmental issue being studied is the use of single-use plastics and how awareness campaigns influence sustainable behavior over time. The first section presents statistical tools and results obtained from survey responses. The bar graph on concern about plastic pollution shows that 53% of respondents are very concerned, 27% are moderately concerned, and 20% are not concerned. This indicates that most participants recognize plastic pollution as an important environmental issue. Plastic waste is a major global challenge because it contributes to ecosystem degradation, marine pollution, and long-term accumulation of non-biodegradable materials in food chains. The pie chart on reusable water bottle use reveals that 60% of respondents always use reusable bottles, 30% use them sometimes, and 10% never use them. This suggests a growing shift toward sustainable consumption practices within the school community. Another pie chart shows that 72% support banning single-use plastics in schools, while 18% oppose the idea and 10% remain unsure. These differences highlight how perspectives can vary depending on environmental concern, convenience, cost, and personal lifestyle choices. The correlation analysis demonstrates a positive relationship between environmental concern and the use of reusable water bottles, with a Pearson correlation coefficient of R equals plus 0.68. This represents a moderate to strong positive correlation, meaning that individuals with greater environmental awareness are more likely to adopt sustainable behaviors. The frequency table further summarizes response distribution and percentages, helping researchers compare patterns quantitatively. The behavior time graph tracks changes in sustainable behaviors over 6 months following an awareness campaign. Reusable water bottle use increased from approximately 45% to 85%. Recycling participation rose from 25% to 70%, and reduction in plastic lunch packaging improved from 15% to 60%. These trends indicate that environmental education and awareness initiatives can significantly influence long-term behavioral change. The possible findings section highlights that perspectives strongly affect attitudes and actions. Students who are more environmentally concerned are more likely to support sustainability initiatives and reduce plastic use. The conclusion emphasizes that collecting and analyzing survey data allows schools to identify behavioral trends, evaluate the effectiveness of sustainability programs, and make evidence-based decisions that support a more sustainable school community and future. Worldviews are the lenses through which groups of people perceive, interpret, and respond to the world around them. In environmental systems and societies, worldviews strongly influence environmental values, perspectives, and decision-making processes. They are shaped by culture, philosophy, religion, ideology, and politics, and they determine how individuals understand environmental problems and sustainability challenges. The first section explains that worldviews influence how people perceive the world, make sense of events and issues, and act within their environment. For example, an environmentalist worldview may prioritize biodiversity conservation and sustainable resource use, while a developmentalist worldview may emphasize economic growth, industrial expansion, and infrastructure development. These differences often shape environmental policies and public attitudes toward climate change, deforestation, or energy production. The central illustration highlights how people develop different beliefs, experiences, values, interpretations, and actions based on their social and cultural backgrounds. Individuals exposed to different education systems, religions, economic conditions, and political ideologies often interpret the same environmental issue differently. For instance, opinions about nuclear energy vary widely depending on concerns related to energy security, economic development, or environmental risks. The second section examines the impact of the Internet and social media. Digital communication exposes people to global connections, diverse ideas, multiple voices, and instant access to information. This can broaden understanding and empathy by introducing individuals to perspectives beyond their local communities. At the same time, social media may also create confusion, misinformation, polarization, or conflict, especially when environmental debates become politically or ideologically driven. Climate change discussions on social media platforms are a strong real-world example of this phenomenon. The lower section emphasizes that perspectives are complex and multidimensional. Environmental models may classify perspectives into categories such as environmentalist, developmentalist, social justice advocate, or traditionalist. However, individuals rarely fit neatly into one category because perspectives are shaped by personal experiences, education, community influences, cultural traditions, media exposure, and changing life events. A person may simultaneously value economic opportunity, environmental protection, and social justice. The complex diagram on the right illustrates how perspectives overlap and interact through factors such as environmental concern, economic priorities, cultural identity, political views, and religious beliefs. This complexity explains why environmental decision-making often involves disagreement and negotiation. The key takeaway is that worldviews shape perspectives, and the digital world expands the diversity of perspectives people encounter. Recognizing these overlapping viewpoints helps develop empathy, critical thinking, respectful dialogue, and more informed environmental decision-making in an increasingly interconnected world. An environmental value system, or EVs, is a model that explains how different influences shape our environmental perspectives and how those perspectives lead to decisions and actions. In IBESS, understanding environmental value systems is important because environmental problems are not solved by science alone, they are also influenced by beliefs, ethics, economics, culture, and political priorities. The diagram begins with inputs, which are the factors influencing how people understand environmental issues. These include information from media such as news, documentaries, television, and social media. For example, media coverage of climate change, wildfires, or plastic pollution can strongly affect public awareness and attitudes. Education and scientific knowledge also shape perspectives by providing evidence from research, environmental monitoring, and sustainability studies. Worldviews are another major input. Beliefs, religion, philosophy, ideology, and cultural traditions influence how societies value nature and development. Social and cultural influences such as family, friends, peer groups, and community norms also affect environmental behavior. In addition, political and economic contexts, including laws, industries, economic systems, and international agreements, shape environmental priorities and policy decisions. These inputs are filtered through our perspectives, shown in the center of the diagram as our lens. Here, values, beliefs, experiences, emotions, cultural identity, and critical thinking interact to influence interpretation and understanding. For instance, two individuals may view deforestation differently. One may prioritize economic development and employment, while another may focus on biodiversity conservation and ecosystem stability. Emotions such as fear, hope, or concern also affect environmental judgment, while critical thinking allows individuals to evaluate evidence more objectively. The Outputs section explains the outcomes of these perspectives. Judgments involve opinions about environmental issues, such as whether climate change is considered urgent. Positions represent support or opposition toward policies or actions. Choices include lifestyle decisions, such as reducing energy use, purchasing sustainable products, or using public transport. Finally, actions involve participation in recycling programs, conservation campaigns, renewable energy adoption, or environmental advocacy. The example at the bottom demonstrates how inputs such as climate change education and media exposure can shape a perspective that humans significantly impact the environment. This may lead to outputs including support for emission reduction policies, choosing sustainable transport, and participating in environmental campaigns. The key idea is that environmental value systems help explain why people think differently about environmental issues and why societies respond differently to sustainability challenges. Understanding these systems promotes informed decision-making and encourages more responsible environmental action for a sustainable future. Environmental perspectives, also called worldviews, can broadly be classified into three categories: technocentric, anthropocentric, and ecocentric perspectives. These perspectives influence how individuals and societies understand environmental problems, evaluate sustainability, and make environmental decisions. The first perspective is technocentric. Technocentrism assumes that human ingenuity, science, and technological advancement can solve environmental challenges. This worldview often prioritizes economic growth, industrial development, and innovation. Key beliefs include confidence that technology will overcome resource shortages, pollution, and climate change. Examples include renewable energy technologies such as solar panels and wind turbines, carbon capture systems, electric vehicles, and geoengineering strategies designed to reduce atmospheric carbon dioxide. For example, some countries invest heavily in nuclear power and advanced renewable technologies because they believe technological progress can maintain economic development while reducing environmental impacts. However, critics argue that over-reliance on technology may ignore social inequalities and ecological limits. The second perspective is anthropocentric, which places humans at the center of importance. Nature is valued mainly for the benefits and services it provides to people, including food, water, energy, medicine, and economic resources. Anthropocentric perspectives often support sustainable development, but primarily to improve human welfare and quality of life. Different anthropocentric views may be influenced by economic priorities, religion, politics, or cultural values. For example, protecting forests may be supported because forests regulate climate, provide timber, support agriculture, and reduce disaster risks for human societies. Sustainable resource management and poverty reduction programs are often associated with this perspective because they aim to balance environmental protection with human development. The third perspective is ecocentric, which views the natural world as having intrinsic value independent of human use. Ecocentrism emphasizes that humans are part of nature rather than separate from it. Key beliefs include respect for biodiversity, ecosystem integrity, conservation, and ecological balance. This worldview supports protecting species and ecosystems even when there is no direct economic benefit to humans. Examples include wildlife conservation programs, deep ecology movements, rewilding projects, and the protection of endangered species such as tigers, elephants, or marine turtles. Ecocentric approaches often advocate living within ecological limits and reducing excessive consumption. The summary at the bottom highlights the major differences among these perspectives. Technocentric views rely on innovation and technological solutions. Anthropocentric views prioritize human welfare and sustainable resource use, while ecocentric views emphasize harmony with nature and respect for all forms of life. Understanding these environmental perspectives is essential in IBESS because real-world environmental decision-making often involves conflict and negotiation between these competing worldviews. Perspectives on the beliefs that support them are not fixed, they change over time as societies gain new information, experiences, and awareness. In environmental systems and societies, understanding how perspectives evolve is important because environmental attitudes, behaviors, and policies are constantly influenced by education, science, culture, economics, and social change. The first section explains that people's beliefs can shift when they encounter new scientific evidence, personal experiences, or different cultural viewpoints. Earlier beliefs may be challenged by environmental education, research findings, or real-world environmental events. For example, increasing scientific evidence about climate change has changed public attitudes toward renewable energy, fossil fuel use, and carbon emissions. Greater access to education, improved communication technologies, and exposure to global environmental problems have also accelerated these changes in perspectives. The second section outlines the major influences that drive change. Government campaigns and policies play an important role through environmental laws, regulations, sustainability targets, incentives, and subsidies. For example, many governments now promote electric vehicles and renewable energy through tax benefits and policy support to reduce greenhouse gas emissions. NGO campaigns and advocacy groups also influence public awareness by promoting environmental education, community engagement, lobbying, and partnerships. Organizations such as Greenpeace and WWF have significantly shaped global awareness regarding biodiversity conservation, plastic pollution, and climate action. Social and demographic changes are another major factor. Urbanization, changing lifestyles, increased education levels, youth activism, and population diversity influence how societies think about sustainability. Young people, especially through global movements such as climate strikes inspired by Greta Thunberg, have played a major role in shifting public concern toward climate justice and environmental responsibility. The example on plastic use demonstrates how attitudes changed over several decades. In the 1990s, plastic bags and bottles were widely accepted because they were cheap and convenient, and environmental concerns were limited. During the early 2000s, scientific evidence and media reports highlighted the impacts of plastic pollution on oceans, wildlife, and human health. By the 2010s, government regulations and NGO campaigns encouraged people to reduce single-use plastics. Today, reusable bags, refillable bottles, recycling programs, and bans on certain plastic products are increasingly common in many societies. The process diagram at the bottom shows how change happens over time. New information leads to discussion, re-evaluation of values, shifts in attitudes, changes in choices and behaviors, and eventually positive impacts on society and the environment. The key message is that perspectives are dynamic. Understanding this helps societies remain open-minded, adapt to new environmental challenges, and work collectively toward a more sustainable future. Behavior time graphs are important analytical tools used in environmental systems and societies to study how human behaviors change over time. These graphs help us understand the influence of education, government policies, technology, social awareness, and cultural change on environmental and social behaviors. By identifying trends, scientists and policymakers can evaluate whether interventions are effective and predict future behavioral patterns. The first example focuses on the reduction in smoking. The graph shows a steady decline in the percentage of smokers from around 50% in 1990 to nearly 10% by 2030. This behavioral change is linked to government awareness campaigns, health education, increased taxation on cigarettes, and smoking bans in public places. Scientific evidence about the health impacts of smoking, including lung cancer and cardiovascular disease, significantly changed public perspectives and behavior. This demonstrates how policy and education can influence long-term social habits. The second example illustrates the reduction in littering incidents between 2000 and 2025. The graph shows a continuous decrease in littering over time. Influencing factors include recycling programs, school awareness campaigns, improved waste disposal facilities, and community participation. Environmental education encourages individuals to understand the ecological impacts of littering, such as soil contamination, blocked drainage systems, and harm to wildlife. Real-world anti-littering campaigns in cities such as Singapore demonstrate how strict regulations combined with public awareness can reduce waste-related problems effectively. The third example examines declining meat consumption over time. The graph indicates a gradual reduction in average meat consumption per person between 1990 and 2030. This trend is associated with increasing awareness of climate change, animal welfare concerns, health consciousness, and the growing popularity of plant-based diets. Scientific studies linking livestock farming to greenhouse gas emissions, deforestation, and high water consumption have influenced consumer choices worldwide. Many people now reduce meat intake to lower their ecological footprint and support sustainable food systems. The fourth example explores changes in indigenous traditional lifestyles. The graph shows traditional practices declining while modern lifestyle practices increase over time. Factors such as urbanization, technological development, internet exposure, formal education, and economic opportunities contribute to this shift. While modernization may improve access to healthcare and education, it can also lead to the loss of traditional ecological knowledge, sustainable land management practices, and cultural identity. The key skills highlighted at the bottom include reading trends, identifying increases and decreases, explaining causes of behavioral change, connecting perspectives with actions, and predicting future trends. Overall, behavior time graphs help us understand how societies adapt over time and how education, policy, and social awareness can encourage more sustainable behaviors and environmental responsibility. The development of the environmental movement has been shaped by many interconnected factors, including influential individuals, literature, media, environmental disasters, international agreements, technological innovation, and scientific discoveries. Together, these forces have increased public awareness, changed societal attitudes, and encouraged collective action towards sustainability. The first influence is individuals. Visionary leaders, scientists, activists, and community organizers inspire social change by challenging existing practices and mobilizing public support. Environmental figures such as Rachel Carson, Wangari Maathai, and Greta Thunberg played major roles in raising awareness about pesticide pollution, deforestation, and climate change. Their efforts demonstrate how individual leadership can influence environmental policies and public behavior globally. Literature has also been highly influential. Books, reports, and essays communicate environmental problems and propose solutions. Rachel Carson's Silent Spring is a classic example because it exposed the ecological impacts of pesticides such as DDT and helped launch the modern environmental movement. Scientific reports from organizations like the IPCC continue to shape global understanding of climate change through evidence-based research. The media further expands environmental awareness through news reporting, documentaries, and social media campaigns. Television programs, online platforms, and documentaries such as Our Planet or An Inconvenient Truth help explain complex environmental issues to wider audiences. Social media now spreads environmental campaigns rapidly, allowing global participation in climate strikes, conservation movements, and sustainability awareness programs. Major environmental disasters often accelerate environmental action because they reveal environmental risks dramatically. Oil spills, chemical leaks, wildfires, floods, and nuclear accidents shock societies and create pressure for stronger environmental regulations. Events such as the Bhopal gas tragedy, the Deepwater Horizon oil spill, and increasing climate-related floods and wildfires have strengthened demands for environmental accountability and improved disaster management. International agreements are another major factor. Treaties such as the United Nations Framework Convention on Climate Change, the Paris Agreement, and the Convention on Biological Diversity encourage countries to cooperate on global environmental challenges. These agreements establish emission reduction targets, biodiversity conservation goals, and sustainability commitments at international levels. New technologies also support the environmental movement by providing cleaner and more sustainable alternatives. Renewable energy systems, electric vehicles, pollution monitoring tools, and energy-efficient technologies help reduce environmental impacts while supporting sustainable development. Finally, scientific discoveries deepen our understanding of environmental systems. Research on climate change, biodiversity loss, ecosystem services, and pollution provides the evidence needed for informed environmental action. Scientific monitoring and environmental modeling allow governments and organizations to predict environmental change and develop effective policies. Together, these influences increase awareness, shape perspectives, mobilize communities, influence policy decisions, and promote collective action toward a more sustainable future. Example of influence: individual activist. This example demonstrates how a single individual can significantly influence the environmental movement by raising awareness, shaping public opinion, and encouraging global action. Their case study focuses on Greta Thunberg, a climate activist from Sweden who became internationally recognized for demanding urgent action on climate change. Her work illustrates how environmental activism can influence governments, businesses, education systems, and public attitudes worldwide. The introduction explains that individuals can inspire change by influencing perspectives and motivating societies toward a more sustainable future. Greta Thunberg began her activism in 2018 by organizing school strikes outside the Swedish parliament under the slogan "School Strike for Climate." Her mission was to highlight the urgency of the climate crisis and pressure political leaders to take stronger climate action based on scientific evidence. The process shown in the center explains how one individual can influence the environmental movement. The first step is speaking out through speeches, social media, and public events to raise awareness. Greta's speeches at international conferences and climate summits gained global attention because they emphasized scientific warnings about rising greenhouse gas emissions, global warming, and future environmental risks. The second stage involves inspiring others. Her activism encouraged millions of young people worldwide to participate in climate strikes and sustainability campaigns. This led to the Global Fridays for Future movement, which mobilized students and communities across many countries. The third stage focuses on influencing decisions by increasing public pressure on governments, industries, and policymakers to strengthen climate commitments and environmental regulations. The fourth stage highlights the creation of global movements. Climate activism spread internationally through media coverage, digital communication, and public demonstrations, making climate change a central issue in political discussions. Finally, these actions contribute to broader environmental change by increasing awareness, encouraging sustainable behavior, and influencing environmental policies. The section on key actions and achievements notes that Greta Thunberg addressed the United Nations Climate Action Summit in 2019, gained major international media attention, and received several awards and nominations for environmental leadership. Her activism also encouraged schools and communities to discuss sustainability, climate science, and environmental responsibility more actively. The impact section demonstrates how individual activism can shape public attitudes, influence stronger climate policies, encourage businesses to adopt sustainable practices, and strengthen climate education globally. Similar examples include Wangari Maathai's Green Belt movement in Kenya and Rachel Carson's influence on pesticide regulation through Silent Spring. The final takeaway is that one person can start a movement, inspire collective action, and contribute to meaningful environmental change. Persistent awareness, communication, and community participation can create significant progress toward a more sustainable future. Example of influence: an author. This example demonstrates how authors can influence the environmental movement through scientific writing, public awareness, and persuasive communication. The central case study is Rachel Carson, an American marine biologist, conservationist, an author whose work transformed global attitudes toward environmental protection. Her writing showed that literature and science together can influence public opinion, government policy, and long-term environmental action. Rachel Carson, born in 1907 in the United States, became internationally known through her 1962 book Silent Spring. The book exposed the harmful environmental impacts of pesticides, particularly DDT, on ecosystems, birds, soil organisms, and human health. Carson's mission was to protect the natural world through scientific evidence and effective communication. At that time, pesticides were widely viewed as beneficial agricultural chemicals, but Carson demonstrated how bioaccumulation and biomagnification allowed toxic chemicals to move through food chains and damage biodiversity. The process shown in the center explains how an author can influence the environmental movement. First, authors conduct research and observe environmental problems using scientific evidence and field observations. Carson carefully documented pesticide contamination and ecological impacts. Second, they write and communicate complex scientific ideas in accessible language through books, reports, essays, and articles. This step is critical because scientific knowledge becomes meaningful only when society can understand it. Third, writing informs and raises awareness among the public. Carson's work encouraged people to question uncontrolled chemical use and recognize the links between human activity and ecosystem health. Fourth, awareness inspires action. Citizens, scientists, and environmental organizations began demanding stricter environmental regulations and safer agricultural practices. Finally, these efforts create lasting impacts by influencing laws, policies, education systems, and conservation programs worldwide. The impact section highlights several important outcomes. Silent Spring became a global bestseller, stimulated scientific review of pesticides, contributed to restrictions and bans on DDT in many countries, and inspired the growth of modern environmental activism. It also helped shape environmental legislation, including the United States National Environmental Policy Act and eventually the creation of stronger environmental regulatory agencies. The slide also presents other influential environmental authors. Garrett Hardin's The Tragedy of the Commons explained resource overuse, although Leopold's A. San County Almanac promoted land ethics and conservation. Elizabeth Colbert's The Sixth Extinction highlighted biodiversity loss, and David Wallace Wells discussed climate risks and future environmental challenges. The key takeaway is that powerful scientific writing can transform perspectives into action. By combining evidence, communication, and public engagement, authors can shape environmental policies, strengthen conservation movements, and encourage societies to protect ecosystems for future generations. Example of influence: media. This example explains how the media can influence environmental awareness and public behavior through documentaries, scientific communication, and visual storytelling. The documentary The Science of Our Planet, released on Netflix in 2021, is presented as a case study showing how environmental media combines science, technology, and emotional narratives to influence global perspectives on sustainability and environmental protection. The documentary explores how climate change affects Earth's natural systems, biodiversity, oceans, and human societies. It explains complex scientific concepts using real-world evidence, satellite imagery, ecological data, and case studies from different ecosystems. The figures on the right highlight major environmental issues discussed in the documentary, including climate change, biodiversity loss, deforestation, pollution, ocean degradation, and unsustainable resource use. Together, these interconnected issues contribute to what is identified as a global environmental crisis. For example, deforestation in the Amazon reduces carbon sequestration, while ocean plastic pollution threatens marine food chains and biodiversity. The central flow diagram demonstrates how media influences society step by step. First, documentaries use compelling visuals and storytelling to communicate scientific facts effectively. High-quality imagery of melting glacier, coral bleaching, and wildfires creates emotional engagement and improves understanding of environmental change. This increases public awareness, allowing viewers to better understand environmental causes and consequences. The next stage involves discussion and sharing. People discuss these issues in schools, communities, and on social media platforms, expanding the reach of environmental information. As awareness grows, behavior change may occur. Individuals may reduce plastic use, conserve energy, adopt sustainable diets, or support renewable energy technologies. This often leads to environmental action, including participation in conservation projects, climate campaigns, and citizen science initiatives. Eventually, growing public concern places pressure on governments and businesses to strengthen environmental policies and sustainability commitments. The scientific communication section highlights how documentaries simplify complex scientific ideas. Scientists explain evidence clearly. Satellite data and advanced monitoring technologies are used to detect environmental trends, and graphs and models help audiences interpret climate and biodiversity data. Visual storytelling makes abstract concepts such as carbon emissions, ecosystem collapse, and species extinction more understandable and emotionally impactful. The Impact section emphasizes that environmental media can inspire youth movements, encourage sustainable lifestyles, influence public opinion, strengthen environmental education, and support conservation efforts worldwide. A real example is how documentaries on ocean pollution increased public support for bans on single-use plastics in many countries. The key takeaway is that environmental media plays a powerful role in shaping attitudes and actions. By combining science, communication, and emotional storytelling, documentaries can transform awareness into meaningful environmental responsibility and collective action toward a more sustainable future. Example of influence: an environmental disaster. This example demonstrates how environmental disasters can transform public attitudes, influence environmental policy, and accelerate environmental movements. The case study presented is the Deepwater Horizon oil spill of 2010, one of the largest marine oil spills in history. The disaster occurred in the Gulf of Mexico between April and July 2010 after an explosion on the offshore drilling platform released millions of barrels of crude oil into the ocean. The incident caused severe ecological, economic, and social consequences, highlighting the risks associated with deep-sea fossil fuel extraction. The first section explains the disaster itself. Oil spread across large marine areas, contaminating coastlines, wetlands, fisheries, and marine ecosystems. Birds, fish, sea turtles, and marine mammals were heavily affected as oil coated habitats and disrupted food chains. Toxic hydrocarbons also reduced water quality and damaged breeding grounds. This illustrates how environmental disasters can destabilize ecosystem structure and function over long periods. The immediate impacts section highlights for major consequences. First, environmental damage included destruction of marine habitats and long-term ecosystem degradation. Second, economic losses affected fisheries, tourism industries, and coastal livelihoods, while cleanup operations cost billions of dollars. Third, human impacts included health risks for workers and coastal populations exposed to oil and chemical dispersants. Finally, intense global media coverage brought worldwide attention to offshore drilling risks and fossil fuel dependence. The middle process diagram explains how disasters influence societal change. The spill raised awareness about the environmental risks of offshore oil extraction and triggered strong public outrage. Communities demanded accountability from corporations and governments. This pressure led to stricter regulations and policy reforms, including stronger offshore drilling safety standards, increased inspections, and improved environmental reporting systems. Oil companies also invested in better monitoring technologies, emergency response systems, and safety procedures. The policy section shows important long-term institutional responses. The United States established the Bureau of Safety and Environmental Enforcement, strengthened environmental impact assessment requirements, and increased transparency in drilling operations. The disaster also encouraged greater investment in renewable energy and alternative energy technologies. The wider influence section demonstrates how disasters can reshape public values and environmental education. Environmental organizations gained more support, consumers became more aware of the environmental costs of energy production, and discussions about climate change and sustainability intensified globally. Similar effects were observed after other environmental disasters, such as the Fukushima nuclear accident and the Bhopal gas tragedy, where public pressure resulted in stricter environmental regulations and industrial safety standards. The key takeaway is that environmental disasters, although tragic, often become catalysts for environmental awareness, policy reform, technological innovation, and stronger commitments toward sustainability and environmental protection. Example of influence: an environmental disaster, Maui wildfires, Hawaii, USA, 2023. This example examines how a recent environmental disaster, the Maui wildfires of 2023, influenced public awareness, environmental policy discussions, and long-term sustainability planning. The fires occurred in Hawaii, USA, during August 2023 and became one of the deadliest wildfire disasters in recent United States history. Severe destruction occurred in Lahaina, where homes, infrastructure, vegetation, and cultural heritage sites were heavily damaged. More than 100 lives were lost, and thousands of people were displaced, demonstrating how environmental disasters can rapidly reshape societal perspectives and policy priorities. The environmental and social impacts section highlights several interconnected consequences. Air pollution and smoke reduced air quality and created serious respiratory health risks. Habitat destruction affected forests, wildlife populations, and biodiversity, while intense heat exposure damaged soils and increased erosion rates. Human impacts included displacement, psychological trauma, and disruption of local livelihoods. Economic losses were also significant because tourism, businesses, and property infrastructure suffered extensive damage. Similar patterns have been observed during Australian bushfires and California wildfires, where environmental and economic systems became highly vulnerable under extreme climate conditions. The slide also explains the major factors contributing to the disaster. Climate change and rising global temperatures increased environmental stress and created hotter, drier conditions. Prolonged drought reduced vegetation moisture, while invasive grasses acted as highly flammable fuel sources. Strong winds associated with Hurricane Dora accelerated fire spread, and urban expansion into fire-prone areas increased human exposure and infrastructure vulnerability. Together, these interacting climatic and human factors increased wildfire risk dramatically. The central process diagram demonstrates how disasters influence society. First, the wildfire caused major destruction and loss of life. Global media coverage then spread images and information worldwide, increasing public awareness about climate change, wildfire risks, and community vulnerability. This awareness encouraged policy discussions about land management, climate adaptation, emergency preparedness, and renewable energy transitions. The final stage emphasizes climate action, where societies increasingly support sustainable planning, resilience building, and cleaner energy systems. Government and community responses included emergency financial assistance, improved warning systems, forest management programs, removal of invasive vegetation, fuel breaks, stronger wildfire-resistant building codes, and investment in climate adaptation strategies. Community rebuilding efforts also focused on sustainability and cultural resilience. The key takeaway is that climate-related environmental disasters are not only ecological events but also social and political turning points. They expose weaknesses in environmental management systems, influence public attitudes toward climate change, and encourage stronger environmental planning, resilience strategies, and sustainable development for the future. Example of influence: international agreements. This example explains how international agreements allow countries to cooperate in solving global environmental problems and create coordinated action for sustainability. Because environmental challenges such as climate change and ozone depletion cross national boundaries, international cooperation becomes essential. The slide compares two major environmental agreements: the Paris Agreement of 2015 and the Montreal Protocol of 1987, both considered landmark achievements in global environmental governance. The first agreement presented is the Paris Agreement, which focuses on climate change mitigation and adaptation. Its main aim is to limit global warming to well below 2 degrees Celsius above pre-industrial levels while pursuing efforts to restrict warming to 1.5 degrees Celsius. Key features include reducing greenhouse gas emissions, establishing nationally determined contributions, or NDCs, promoting renewable energy transitions, strengthening climate adaptation, and encouraging global cooperation and transparency. These measures influence society by supporting stronger climate policies, increasing renewable energy investment, improving public awareness, and contributing towards sustainable development goals. For example, many countries expanded solar and wind energy programs after committing to Paris climate targets. The second agreement is the Montreal Protocol, designed to protect the ozone layer by phasing out ozone-depleting substances such as chlorofluorocarbons, or CFCs. Unlike many environmental agreements, the Montreal Protocol included legally binding reduction targets and strong scientific monitoring systems. Key features include international cooperation, development of safer chemical alternatives, and continuous monitoring of ozone recovery. The influence on society has been highly significant. The ozone layer is gradually recovering, harmful ultraviolet radiation reaching Earth has decreased, and risks such as skin cancer, cataracts, and ecosystem damage have been reduced. This agreement is often viewed as one of the most successful examples of global environmental cooperation. The comparison table highlights important differences between the two agreements. The Paris Agreement mainly targets greenhouse gas emissions and climate resilience through national commitments and cooperative action, while the Montreal Protocol specifically targets ozone-depleting substances through legally binding phase-outs. Both agreements demonstrate how international cooperation can address large-scale environmental problems using science, policy, technology, and public participation. The central process diagram explains how international agreements create change. Countries first negotiate shared goals and responsibilities. Governments then develop national laws, strategies, and action plans to meet commitments. Public awareness increases through education and media communication, encouraging behavioral changes among individuals and industries. Environmental action then occurs at multiple levels, eventually contributing to global sustainability and improved environmental quality. The key takeaway is that international agreements such as the Paris Agreement and the Montreal Protocol show how global cooperation can influence environmental policy, stimulate innovation, strengthen environmental responsibility, and create long-term benefits for ecosystems, economies, and future generations. Example of influence: international agreements, COPs. This example explains how international agreements influence global environmental governance and encourage countries to cooperate in solving shared environmental challenges. Environmental problems such as climate change, biodiversity loss, pollution, and ozone depletion cross national boundaries, meaning that no single country can solve them independently. International agreements create formal commitments between nations, encouraging cooperation, shared goals, and collective environmental action. The first section explains the purpose of international agreements. These agreements recognize that environmental issues are global in scale and require shared responsibility, although countries may contribute differently depending on their economic development and historical emissions. Agreements establish frameworks, targets, and action plans that guide national environmental policies and encourage accountability. The central focus is on United Nations climate change conferences, commonly known as COP meetings, including COP21 in Paris and COP27 in Sharm el-Sheikh. These conferences bring together governments, scientists, businesses, NGOs, and international organizations to negotiate climate action strategies. Their main purpose is to limit global temperature rise, strengthen climate adaptation and resilience, mobilize climate finance and technology, and review progress toward international climate goals. The middle process diagram shows how international agreements influence the world step by step. First, countries engage in global negotiations to discuss common goals and responsibilities. Second, agreements and commitments are established, such as greenhouse gas emission reduction targets. Third, nations implement policy actions by creating laws, climate strategies, renewable energy plans, and environmental regulations. These agreements also stimulate investment and innovation by encouraging funding for clean technologies, renewable energy systems, and low-carbon infrastructure. The overall global impact includes reduced emissions, ecosystem protection, and movement toward more sustainable development pathways. Finally, review and accountability systems monitor national progress and encourage countries to strengthen commitments over time. The examples section highlights COP21 and COP27. At COP21 in Paris during 2015, countries adopted the Paris Agreement, aiming to keep global warming well below 2 degrees Celsius and pursue efforts to limit warming to 1.5 degrees Celsius. Nations submitted nationally determined contributions, or NDCs, outlining emission reduction plans. COP27 in Egypt focused more strongly on implementation, adaptation, resilience, and financial support for vulnerable nations experiencing climate-related loss and damage. The positive influences of international agreements include stronger global cooperation, increased climate finance, technological innovation, public awareness, and pressure for stronger national environmental policies. For example, many countries accelerated investments in solar and wind energy after Paris Agreement commitments. However, challenges remain, including political disagreements, unequal economic capacities, insufficient climate finance, weak enforcement mechanisms, and changing political priorities that may delay implementation. The key takeaway is that international agreements demonstrate how global cooperation can shape environmental policy, stimulate technological innovation, and support collective action toward a more sustainable and climate-resilient future. Example of influence: international agreements, the Kyoto Protocol. The Kyoto Protocol is one of the earliest major international agreements created to reduce greenhouse gas emissions and address global climate change. Adopted in Kyoto, Japan, in 1997 under the United Nations Framework Convention on Climate Change, or UNFCCC, it became legally binding for developed countries, known as Annex I parties, and officially entered into force in 2005. The agreement represented a major shift from simply discussing climate change to establishing measurable emission reduction targets and accountability mechanisms. The central aim of the Kyoto Protocol was to lower emissions of major greenhouse gases such as carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. By reducing these gases, the agreement aimed to slow global warming, encourage cleaner energy systems, strengthen international cooperation, and protect environmental quality for future generations. This helped stimulate global interest in renewable energy technologies such as solar, wind, and energy-efficient systems. For example, several European countries significantly expanded renewable electricity generation after adopting Kyoto-related climate policies. The protocol introduced several important features. Developed countries were assigned emission reduction targets, while market-based mechanisms such as carbon trading allowed countries to buy and sell carbon credits. The Clean Development Mechanism, or CDM, enabled developed nations to invest in sustainable projects in developing countries, including reforestation, methane capture, and renewable energy projects. Joint implementation projects encouraged cooperation between industrialized nations. Monitoring, reporting, and verification systems were also established to track progress scientifically and transparently. The process diagram explains how the agreement worked. Countries first established emission targets, then implemented national policies and environmental projects, reduced emissions through technological and economic changes, and finally reported and reviewed progress internationally. This created a framework for accountability and continuous improvement. The protocol also influenced society and environmental policy in several ways. It increased global awareness about climate change, encouraged governments to create stronger environmental laws, stimulated innovation in cleaner technologies, and strengthened international cooperation. Many nations introduced climate action plans, energy efficiency standards, and carbon management policies during this period. However, the Kyoto Protocol also faced criticism. Some major emitters, including the United States, did not ratify the agreement. Participation by developing countries was limited, enforcement mechanisms were difficult, and global emissions continued to rise overall because of increasing industrialization and fossil fuel dependence. The key takeaway is that the Kyoto Protocol laid the foundation for future climate agreements, including the Paris Agreement. It demonstrated that international cooperation, science-based targets, and policy coordination are essential for addressing global environmental challenges and promoting a more sustainable future. Example of influence: technological developments, Green Revolution. The Green Revolution refers to a period of rapid agricultural development from the 1940s to the 1980s that dramatically increased food production, particularly in developing countries. Its primary aim was to reduce hunger, improve food security, and increase crop yields per unit area using advanced farming technologies and scientific management practices. Countries such as India, Mexico, and the Philippines experienced major transformations in agricultural productivity during this period. At the center of the Green Revolution were several important technological innovations. High-yielding varieties, or HYV seeds, were genetically improved crops designed to produce much larger harvests than traditional varieties. These were supported by expanded irrigation systems, allowing crops to receive reliable water supplies throughout the growing season. Farmers also increased the use of chemical fertilizers containing nitrogen, phosphorus, and potassium, commonly represented as NPK, along with pesticides to control pests and diseases. In addition, mechanization through tractors, harvesters, and modern farming machinery improved efficiency and reduced labor demands. Advances in plant breeding, agronomy, and agricultural research played a critical scientific role in supporting these changes. The Green Revolution was developed in response to rapid population growth after World War II, widespread food shortages, and fears of famine in many developing nations. Governments, research institutions, and international organizations invested heavily in agricultural modernization to increase food production without continuously expanding farmland. For example, India's wheat production increased dramatically during the 1960s and 1970s, helping the country move closer to food self-sufficiency. The impacts were both positive and negative. On the positive side, crop yields of rice, wheat, and maize increased significantly, food prices decreased in many regions, and agricultural growth contributed to economic development and rural employment. Millions of people benefited from improved food availability. However, there were also serious environmental and social consequences. Intensive fertilizer and pesticide use contributed to soil degradation, water pollution, and biodiversity loss. Over-irrigation depleted groundwater resources in many agricultural regions. In some areas, wealthier farmers benefited more because they could afford machinery, irrigation systems, and chemical inputs, while smaller farmers were sometimes left behind economically. Overall, the Green Revolution demonstrates how technological development can transform food systems and improve human survival, but it also highlights the importance of sustainable agriculture that balances productivity with environmental protection and social equity. Example of influence, technological developments, enteric fermentation. Enteric fermentation is a natural biological process that occurs in the digestive systems of ruminant animals such as cows, sheep, and goats. These animals have a specialized four-chambered stomach consisting of the rumen, reticulum, omasum, and abomasum. Inside the rumen, microorganisms break down cellulose-rich plant material through anaerobic fermentation, allowing animals to digest grasses and other fibrous foods that humans cannot digest directly. However, this microbial process also produces methane, or CH4, which is released mainly through eructation, or burping. The methane production pathway begins when the animal consumes plant material. Microbes in the rumen decompose the fiber and generate hydrogen and carbon dioxide as byproducts. Specialized microorganisms called methanogens then convert hydrogen and carbon dioxide into methane gas. This is environmentally significant because methane is a highly potent greenhouse gas with a global warming potential approximately 28 to 34 times greater than carbon dioxide over a 100-year period. Livestock agriculture therefore contributes substantially to global greenhouse gas emissions, especially in countries with large cattle industries such as Brazil, India, and the United States. To reduce enteric methane emissions, scientists and agricultural researchers are developing several technological solutions. Improved feeds and dietary additives, including fats, tannins, oils, and seaweed supplements, can reduce methane production in the rumen. For example, research on red seaweed species such as Asparagopsis has shown significant reductions in methane emissions in experimental cattle systems. Probiotics and microbial management approaches aim to alter rumen microbial communities to suppress methane-producing pathways. Vaccines targeting methanogenic microbes are also under investigation. Selective breeding programs focus on identifying animals that naturally emit lower methane levels, while manure management systems can capture biogas for renewable energy production. The importance of these technologies extends beyond climate mitigation. Livestock provide food, nutrition, income, and livelihoods for billions of people worldwide. Reducing methane emissions supports sustainable livestock production, improves agricultural efficiency, and contributes to global climate goals. However, challenges remain, including the cost of technology, limited access for small-scale farmers, and the need for continued scientific research, education, and policy support. The key takeaway is that enteric fermentation is a natural agricultural process, but technological innovation offers promising opportunities to reduce greenhouse gas emissions while maintaining food security and supporting more sustainable farming systems. Example of influence: scientific discovery, technological developments, plant-based meats. Plant-based meats are foods created from plant ingredients that are designed to look, cook, and taste similar to animal meat. They represent an important technological development aimed at creating more sustainable food systems while reducing the environmental pressures associated with livestock production. Common examples include plant-based burgers, mince, and sausages that use ingredients such as pea protein, soy protein, wheat gluten, chickpea protein, vegetable oils, natural flavorings, vitamins, and color additives to imitate the texture and nutritional profile of conventional meat. The production process involves several technological stages. First, raw plant materials are selected and processed. The ingredients are then mixed, ground, and texturized using extrusion technology, which creates fibrous structures similar to muscle tissue in meat. The mixture is shaped into familiar products such as burger patties, sausages, or strips, and finally prepared for cooking like traditional meat products. Advances in food science help improve flavor, color, aroma, and mouthfeel, while emerging technologies such as 3D food printing may eventually create more realistic whole-cut alternatives. Companies such as Beyond Meat and Impossible Foods are examples of businesses using biotechnology and food engineering to develop these products. One of the most important aspects of plant-based meats is their environmental benefit compared with beef production. Studies suggest they can generate around 90% lower greenhouse gas emissions, use 82% less water, require 93% less land, and reduce feed demand by approximately 94%. This is significant because livestock farming is a major contributor to methane emissions, deforestation, biodiversity loss, and freshwater consumption. Replacing even part of global meat consumption with plant-based alternatives could therefore reduce pressure on ecosystems and help mitigate climate change. There are also additional social and economic benefits. Plant-based meats are often lower in saturated fat and cholesterol, may support animal welfare by reducing dependence on intensive farming, and can improve food security because plant proteins are generally more resource efficient to produce. The sector also creates innovation and employment opportunities in food technology industries. However, several challenges remain. Many products are more expensive than conventional meat, some are highly processed and contain additives, consumer acceptance varies across cultures, and manufacturing can require substantial energy inputs depending on production methods. The key takeaway is that plant-based meats are not a complete solution on their own, but they demonstrate how technological innovation can reduce the environmental impacts of food production while supporting more sustainable and resilient diets for the future. Example of influence: scientific discovery, pesticide and biocide toxicity. Scientific discovery of pesticide and biocide toxicity has fundamentally changed how societies regulate chemicals and protect both human health and ecosystems. Through laboratory testing, wildlife field studies, and epidemiological research on human populations, scientists discovered that many pesticides designed to kill pests could also harm non-target organisms, contaminate ecosystems, and accumulate in food chains. One of the most influential discoveries involved DDT, which caused eggshell thinning in birds such as eagles and falcons, leading to severe population declines. Other organophosphate pesticides were linked to nerve damage and neurological disorders in humans. The process of identifying toxicity begins when chemicals are applied to the environment and organisms such as humans, animals, plants, or microorganisms become exposed. Scientists then study biological responses including cell damage, reproductive problems, behavioral changes, developmental abnormalities, or mortality. Data from controlled experiments and long-term environmental monitoring are analyzed to determine toxicity risk. Important scientific indicators include LD, which measures the lethal dose required to kill 50% of test organisms, and NOAEL, the no observed adverse effect level. Researchers also investigate bioaccumulation and persistence, which explain how chemicals concentrate within organisms and remain in ecosystems for long periods. These discoveries produced major environmental and policy changes. Governments introduced stricter regulations, mandatory safety testing, exposure limits, and in some cases outright bans on hazardous chemicals. International agreements such as the Stockholm Convention and Rotterdam Convention were created to control persistent organic pollutants and dangerous pesticides globally. Scientific evidence also encouraged the development of safer alternatives and integrated pest management, or IPM, which combines biological control, crop rotation, resistant crop varieties, and limited chemical application to reduce environmental harm. The toxic effects summarized in the table demonstrate the wide ecological impact of these substances. Humans may experience cancers, endocrine disruption, reproductive disorders, and neurological damage. Wildlife can suffer reduced reproduction and behavioral abnormalities, while aquatic organisms may experience fish kills and ecosystem disruption. Beneficial insects such as bees face pollination decline and biodiversity loss, threatening food production systems. For example, concerns about neonicotinoid pesticides have led several countries to restrict their use because of links to bee population decline. The broader significance of this scientific discovery is that it transformed chemical management from uncontrolled usage toward evidence-based environmental regulation. It highlights how scientific research informs policy, protects biodiversity, improves public health, and supports more sustainable agricultural systems for the future. Example of influence: scientific discovery, habitat destruction. Scientific discoveries about habitat destruction have transformed our understanding of biodiversity loss and ecosystem decline, influencing environmental policy and conservation worldwide. Researchers discovered that activities such as deforestation, urbanization, agricultural expansion, and mining fragment and destroy natural habitats, reducing species populations and disrupting ecosystem stability. Using remote sensing satellites, field studies, ecological experiments, and computer-based modeling, scientists identified habitat loss as one of the leading causes of species extinction and declining ecosystem resilience. Scientific evidence revealed a clear chain of ecological impacts. When natural habitats are cleared or degraded, species lose food sources, shelter, breeding grounds, and migration pathways. As populations decline, important ecosystem functions such as pollination, water regulation, soil fertility, and carbon storage are also reduced. This directly affects human societies through increased flooding, reduced clean water availability, soil erosion, and weakened climate regulation. For example, destruction of tropical rainforests in the Amazon not only threatens biodiversity but also reduces the forest's ability to store carbon dioxide, contributing to global climate change. The evidence supporting these discoveries comes from long-term ecological studies, biodiversity monitoring programs, species population databases, and climate ecosystem modeling. Scientists have tracked dramatic declines in species such as orangutans due to forest clearing in Southeast Asia and coral reef degradation caused by coastal development and pollution. These findings demonstrate the close relationship between ecosystem health and human well-being. As a result, scientific discoveries about habitat destruction have strongly influenced conservation policies and environmental management. Governments and international organizations established protected areas, wildlife corridors, land use planning regulations, and environmental impact assessments. Habitat restoration projects, including reforestation and wetland recovery, aim to rebuild damaged ecosystems. Stronger environmental laws now limit uncontrolled deforestation, urban sprawl, and industrial expansion in ecologically sensitive regions. International agreements such as the Convention on Biological Diversity encourage global cooperation in biodiversity conservation. The examples shown, deforestation, urbanization, agricultural expansion, and mining, illustrate the wide range of human pressures affecting natural habitats. In response, scientists, policymakers, and communities promote sustainable land use practices such as agroforestry, responsible development, and ecosystem monitoring to reduce further damage. The key takeaway is that scientific discovery has helped societies recognize that healthy ecosystems are essential for biodiversity, climate stability, and human survival. This understanding has driven stronger conservation actions and supports the transition toward a more sustainable future. Example of influence: scientific discovery, biodiversity loss. Scientific discovery has revealed that biodiversity is declining at an unprecedented rate due to human activities, and this knowledge has greatly influenced environmental policy, conservation efforts, and public awareness worldwide. Scientists collect evidence through field studies, satellite monitoring, DNA analysis, species surveys, and long-term ecological research to understand how ecosystems and species populations are changing over time. These scientific methods allow researchers to track environmental change with increasing accuracy and identify global biodiversity trends. One major source of evidence is the Living Planet Index, which shows a significant decline in global wildlife populations between 1970 and 2020. Scientists estimate that current species extinction rates are now approximately 100 to 1,000 times higher than natural background extinction rates. Ecosystems across the world are becoming increasingly degraded, affecting both terrestrial and aquatic biodiversity. For example, coral reef ecosystems are experiencing severe bleaching due to rising ocean temperatures, while tropical rainforests continue to lose species because of deforestation and land conversion. The major causes of biodiversity loss include habitat destruction and fragmentation caused by deforestation and urbanization, pollution from plastics and industrial chemicals, overexploitation through overfishing and illegal wildlife trade, climate change leading to warming and ocean acidification, and invasive species that outcompete native organisms. These pressures often interact, creating cumulative environmental stress. For instance, amphibian populations worldwide have declined because habitat loss, pollution, disease, and climate change act simultaneously on already vulnerable species. The consequences of biodiversity loss extend far beyond the extinction of individual species. Ecosystem services such as pollination, water purification, soil fertility, and climate regulation become weaker. Food security is threatened because agriculture and fisheries depend heavily on healthy ecosystems. Economic costs also increase as societies spend more on disaster recovery, environmental restoration, and resource management. The decline of pollinators like bees, for example, directly affects global crop production and agricultural economies. Scientific discoveries about biodiversity loss have strongly influenced society by informing environmental policies and international agreements such as the Convention on Biological Diversity and the Kunming-Montreal Global Biodiversity Framework. This research also raises public awareness and encourages conservation action, sustainable resource use, pollution reduction, habitat restoration, and global cooperation. The key takeaway is that biodiversity supports life on Earth, including human survival. Scientific understanding of biodiversity loss helps societies recognize the urgency of protecting ecosystems and guides informed action toward a more sustainable future.